All right, team, let's talk about one of my absolute favorite shortcuts in Python, the Lambda function. If you've ever found yourself writing a whole function with def just for one tiny little task and thought, man, this feels like overkill, well, you're in exactly the right place. Let's dive in.
So, what's the big deal? Just look at this. On the left, you've got your standard everyday function. You've got the def keyword, a name, the whole ceremony. But on the right, that's a lambda. It does the exact same thing, but in one clean, simple line. This is what we're here to master, writing these quick, disposable functions without all that extra boilerplate.
So, how in the world does this work? Well, the whole secret is that we're creating what's called an anonymous function. Think about it. Sometimes you just need a function for a single, fleeting moment. Giving it a full name with def feels a little dramatic, right? That's the perfect time to use a lambda.
Okay, so here's the official definition. A lambda is a small anonymous function. The key things to burn into your memory are the lambda keyword itself and this one big rule. You can throw as many arguments at it as you want, but you only get one single expression. And as we'll see, that limitation is actually its greatest strength. To really get your head around this, I want you to think of a lambda as a sticky note for your code. Seriously, this analogy is going to make everything click. So a regular def function, that's like a formal typed-up document. It has a name, it's meant to be filed away and reused, and it's perfect for complex, multi-step logic. A lambda, on the other hand, that's your sticky note. You just scribble down one quick instruction for a single-use task, stick it where you need it, and then you're done. You mentally toss it. No name, no ceremony, just a job done quickly. The syntax might look a little weird at first, but it's actually super simple. First, you start with the keyword lambda. Then, you just list your arguments, your inputs, no parentheses needed. After the colon, that's where you put your single expression, that one thing the function does. And whatever that expression evaluates to gets returned automatically. Let's see it in action. Here, we're creating a lambda that takes one argument, a, and its expression is simply a times a. We're assigning this little function to the variable square. So now that variable square is a function. We can call it like square of 5, and bam, the result is 25. And yep, it works with multiple arguments, no problem. This lambda takes a and b, and its entire job is to add them together. So when we call add 5, 6, we get 11. See? Any number of arguments, as long as the work itself is just one simple expression. I'm going to say this one more time because it is the most important rule of the game. You can't have multiple lines of code, you can't have complex if-else blocks, and you never ever use the return keyword. The result of that one expression is just returned for you. That's what keeps our lambdas simple and clean, just like a sticky note. Okay, so you might be thinking, this is kind of neat, but why not just use def for everything? And that is a great question. The answer is right here. This is where lambdas truly shine, when they're used as helpers for other, bigger functions, like map and filter. All right, for our next couple of examples, we're going to be working with this simple list of numbers. Nothing fancy. So first up, here's our mission. We need to filter this list down so we're only left with the even numbers. How can we pull this off in a really clean Pythonic way?
This is a perfect job for a lambda. The built-in filter function needs a little helper function, a test it can run on every single item. And our lambda num, some num %2 equals 0, is that perfect tiny test. It's a disposable sticky note function whose only job is to return true if a number is even and false if it's odd. And here is the solution. Look how elegant that is. It's all on one line. We passed our lambda, our sticky note instruction, directly into filter. We didn't have to go to find a whole separate is-even function somewhere else. We just wrote the logic right there, exactly where we needed it. It's so clean. The map function is another classic place you'll see lambdas. Instead of filtering things out, map transforms every item in a list. So right here, we're using a lambda to tell map, hey, for every number x you see, I want you to give me back x times x. And just like that, we get a brand new list with all our numbers squared. Same idea, a simple one-off operation passed into another function. Now for a really crucial piece of senior dev advice. Just because you can use a lambda doesn't always mean you should. Remember, our number one job as developers is to write code that other people and our future selves can actually understand. So can a lambda get too complicated? Oh, you bet it can. And when it does, it means you're using the wrong tool for the job. I mean, just look at this thing.
Technically, this is valid Python code, but it is an absolute nightmare to read. It's all crammed onto one line with nested logic. If you have to stare at a line of code for more than 5 seconds just to figure out what's going on, it's probably bad code.
So here's the rule of thumb I always use, the sticky note test. If the logic you need is too complicated to jot down on a simple mental sticky note, it's time to upgrade. Promote it to a full named def function with proper formatting. Your teammates and your future self will thank you.
Okay, as you start writing your own lambdas, you're going to hit a few common snags. It happens to literally everyone. So let's go over the usual suspects right now so you know what to look for. You'll probably see a syntax error if you accidentally type a return statement. Just remember, the return is totally implicit. You'll get a type error if you define it to take one argument, but you try to give it two. And trust me on this one, it is weirdly easy to just forget to type the lambda keyword at the very beginning. All right, we've covered the theory, but the only way this is really going to stick is if you write some yourself. I've got a couple of quick challenges for you. Feel free to pause after each one and give it a shot. First one up is a simple true-false check. How would you write a one-line anonymous function to figure out if a number is positive?
And for challenge number 2, I want you to use map to transform this list of strings, hello world, so that each word has an exclamation point at the end. Give it a try. Because what makes a lambda so powerful isn't just knowing the syntax, but developing the instinct for when its focused, simple power is the perfect tool for the job. Happy coding!